So these were the two questions that were on your Canvas lesson. Let's just do them together fairly quickly here. And so the lowest temperature recorded in Antarctica was negative 129 degrees Fahrenheit at the Russian Vostok station in 1983. Use only this fact to write and graph an inequality that describes the temperatures in Antarctica. So we need to write and make a graph, right? Okay, so this was the lowest temperature was negative 129. So negative 129, oops, I'm putting that in the wrong spot. Let's try this again. So negative 129 is the smallest number when compared to our temperatures. So our temperatures are always bigger than this. So the symbol we want in between is a greater than or equal to sign, or with the x, with the big end eating the x, right? Because this shows that all temperatures are larger than negative 129. And if I was going to graph that, there's my negative 129. Let's add a couple numbers just for flavor here. So how do I graph this thing here? First of all, it's a closed circle on negative 129. Closed circle on negative 129. And we are representing all of the numbers larger than negative 129, which means we are going to the right. And the graphs that I gave you look something like this. They were smaller numbers. This was 8, 9, 10, 7, 6, 5. And we had an open circle to the right. The inequality that represents this would be 8, and its numbers larger than 8, so I want the symbol to be greater than. Notice again it's an open circle, so that means it's a greater than, not the equal to, and the x is on the bigger side because it's everything larger than 8. And the second one that I have for you here was looking like negative 3, negative 2, negative 1, negative 4, negative 5. We had a closed circle there. Everything to the left. So how do we represent this one? Well, again, x starting on negative 3. It's a closed circle, so I know this is an equal to. And so what are we representing here? We're representing all the numbers smaller than negative 3, which means we want the small end heading towards the x. Again, if you have any questions on this, feel free to comment on the video and I can try to help you out there, or you can go back to your Canvas lesson and you can reach me in some way that way, okay? Let's move on to some solving. Solve an inequality using addition. So first of all, let's talk about, before we actually do this example, let's remember a couple of things, right? What does it mean to solve? To solve something means to isolate the variable. That is, get the variable by itself. Isolate the variable. Be by yourself. So we need to get the x by itself in this case. How do we do that? Well, we use our solving steps, right? And these are the same solving steps that you use with equations. That's the really nice thing about doing this with inequalities, is that if you know how to solve an equation, you know how to solve an inequality. So remember, the solving steps here are this. We do opposite operations. We undo things, right? We undo the operations in order to get the x by itself. And whatever operation we do, operations we do to both sides of the inequality. And again, we do this to keep that balance, right? We have the, let's use some colors here. We have the left side of the inequality, and we have the right side of the inequality And whatever we do to the left-hand side, we need to also do to the right-hand side. Whatever we do to the right-hand side, we also have to do to the left-hand side. Let's just clarify this. This says x minus 5 is greater than negative 3.5. In case you were thinking that said x minus 57, it doesn't. It says x minus 5 is greater than negative 3.5. So we have the left-hand side and the right-hand side. Whatever we do to one side, we have to do to the other side. And we are trying to isolate the variable. And we do that by undoing the operation. So this particular one is a fairly simple one-step operation. This is subtract 5. So we're going to add 5 to both sides. When we do that, we get negative 5 plus 5 on this side, which is 0. And so, right, x minus 0, that's just 0. Is greater than negative 3.5 plus 5. That looks like 1.5 to me. So that's x is greater than 1.5. So we've solved this inequality, excuse me. This inequality is solved for. We have isolated the variable by itself on one side. We can graph that, by the way, just like we did on the previous problems. If this is 0, negative 1, 1, and 2, I have an open circle at 1.5, and then this is everything greater than that. So it's everything to the right. If we're being asked to graph those, we can. And it looks something like that. So we can solve an inequality using addition the same way we did it as if this were an equal sign. It is exactly the same. These first couple ones we're doing here are going to be fairly simple one-step things. Let's do one more. This is 9 is greater than or equal to x plus 7. So I'm going to use opposite operations to get the variable by itself, which means I'm going to subtract 7. And notice that I'm doing that to both sides of the inequality. So I end up with 2 is greater than or equal to x. And that is now solved because the x is by itself. We can also graph this. 0, 1, 2, let's add some more just for flavor. Come on now. There we go. So this is a closed circle on 2. And you do got to think about it a little bit, right? The x is on the right-hand side of the equation this time. So which way is our arrow going to go? Notice that it's the smaller side is coming for the x. So I'm going to be going, we're saying x is smaller than 2, which means we're going everything to the left. You do have to be careful and read the inequality a little bit there. So go on back to your Canvas lesson. There's a couple of problems for you to do. Again, if you want to skip to if you're watching this and you don't have access to Canvas, you can skip to the next lesson and see those problems. And do try those on your own, and we'll solve them in the next video.